Okay. No. Any more doubt? Now the next topic, that is hydrogenation. Practical organic chemistry. The topic is hydrogenation. See here. What is hydrogenation? Addition of hydrogen. Is called hydrogenation. Second, point number 2. The reagent used H2PT, H2 on platinum or H2 on palladium or H2 on nickel, or sometimes the people also say H2 Rane nickel. It hardly matter. See this. Hydrogenation means addition of hydrogen. In case of hydrogenation means addition of hydrogen, and here the typical agents are H2 on palladium, hydrogen gas on palladium or platinum or nickel or Rane nickel. A lot can be discussed about this hydrogenation, the energetics of hydrogenation, the catalyst of hydrogenation, the process, the molecular process of hydrogenation. But we are not going into that very details, because we are not going into the detail part. We are going for the problem solving. Our aspect is practical organic chemistry. How to solve the questions related with hydrogenation. See this. A lot can be discussed about the process, how it takes place. But we are not going on to that very details. See, the reason is very simple. We are limited to problem solving, that is more or less factual based, some technique based. Addition of hydrogen is called hydrogenation. Reagent used is H2PT, H2PT. Point number 3. In hydrogenation, the carbon skeleton remain unchanged. Point number 4. One pi bond is equivalent to one H2 molecule. And fifth, In this process, all unsaturated alkene or alkyne gives saturated alkanes. See, a lot can be discussed about this. There are many examples of partial hydrogenation where alkyne gives alkene, but we are not going to discuss all those. The reason is we are very much specific to problem solving. What about practical organic chemistry? All unsaturated alkene alkyne gives saturated alkanes. Carbon skeleton remain unchanged, and this is called hydrogenation. The reagent are this one. 5, 6. All positional isomeric alkenes or alkynes gives same hydrocarbon, same alkane, same saturated compound hydrocarbon on hydrogenation. This concept is very simple. Addition of H2 is called hydrogenation. Reagent using H2PT, H2PD, H2 nickel, H2 ranitidine. In hydrogenation, the carbon skeleton remain unchanged. One pi bond is equivalent to one H2 molecule. All unsaturated alkene or alkyne gives saturated alkanes. All positional isomeric alkenes or alkynes give same saturated hydrocarbons on hydrogenation. This point is somewhat problematic. Otherwise, it is very simple. Let us see by examples what it says. Suppose let we have this compound. This on hydrogenation gives what? H2PD. What is the product? This is the pi bond. This one unsaturated. The hydrogen add on the pi bond. Hydrogen add on the pi bond. And pi bond get converted to sigma bond. What this mean? In this process, one pi bond consumes one hydrogen molecule. See this. A simple layout. It will say a lot of things. Point number 1, this is unsaturated. This is saturated. This has 2 du. This has 1 du. This is what? C7H12. This is what? C7H14. One more thing, carbon skeleton remains same. The whole concept of monoclination or hydrogenation or ozonolysis. It's just like the story of Panchtantra, where four Brahman boys were traveling through river riverside and they came across a corpse, and that was of lion. See, the same thing is here. We have to manage which compound is there earlier. This is the product. What this mean? This is saturated. This must have come from unsaturated compound if formula is given. See this. 2 du, 1 du. Why 2 du? This has 2 du. 1 du in pi bond, 1 du in cycle. After hydrogenation, the cycle does not get disturbed. Carbon skeleton remains same. Again, this is cyclic. But pi bond get disturbed. In place of pi bond, we add hydrogen. The 2 valency that has gone to pi bond is now get converted to sigma bond. This is the approach. This is called hydrogenation. This is the typical reagent H2PD. What is happening? Unsaturated and saturated. Cycle will not disturb, carbon skeleton remains same. We can compare the formula. C7H12, 2 du. C7H14, 1 du. What this mean? This imply 1 pi bond is there. Or in other way, number of pi bond is equal to change in hydrogen divided by 2. The difference is 2. Why 2? Because 1 pi bond is there. See this. That is a technique. This is about hydrogenation. Now, I have to discuss one more point. See, how many structurally isomeric alkene with molecular formula C7H12 gives methyl cyclohexane on hydrogenation. See this. Technically, if you go by NCERT and so on, this question belongs to the chapter alkene. But no one is going to solve those questions there because of the nature of question. In alkene, whenever we go through alkene, we talk about mechanism. See, how many structurally isomeric alkene molecule from this one? The reactant is C7H12. C7H12. Product is methyl cyclohexane. What is methyl cyclohexane? This is your methyl cyclohexane. This is methyl cyclohexane. Again, this has how many DU? 1. This formula has how many DU? 2. What does this mean? This implies this has 1 pi bond. And the question is what? What is the question? How many structurally isomeric alkene? Now we have to arrange alkene. We have to arrange pi bond on this skeleton. See this. And we can say that either pi bond can be here, methylene cyclohexane, or pi bond can be here, 1 methyl cyclohexene, or pi bond can be here, 3 methyl cyclohexene, or pi bond can be here, 1, 2, 3, 4 methyl cyclohexene. See this. This is your methylene cyclohexane, and this is your 1, 2, 1 methyl cyclohexene. This is your 1, 2, 3, 3 methyl cyclohexene. This is your 1, 2, 3, 4, 4 methyl cyclohexene. The answer is 4. Means all of these on hydrogenation gives same skeleton. Try to understand this. This is the beauty of this part. All isomeric alkene gives same product on hydrogenation. What this mean? Here the question may be asked about number of isomeric alkene, or question may be further asked with correlation with monoclination. See, 1, 2, 3, 4, 5. This will give 5 monochloro product. The question may ask further, how many monochloro product will be obtained if an organic compound with isomeric alkene with this formula get monoclonal. See, in this way, the question can be mixed and remixed. Try to understand this. The problem with NCERT is no one is going to discuss these questions. Where to discuss these questions? There is no such chapters. But they ask questions. In NCERT, when you go through the NCERT, they talk a lot about mechanism. But how to answer these questions? See this. How many structurally isomeric alkenes molecular formula C12 gives methyl cyclohexane on hydrogenation? See. Now see. Find number of isomeric alkenes for each one product obtained after hydrogenation by adding 1 mole H2 per mole. See this. 1. 2, 3, 4. See, very simple questions. What this mean? These are the products. What is the reactant? Reactant was added 1 mole hydrogen. This implies reactant must have 1 pi bond. How many isomeric alkene? See, for this one, the skeleton remains same. See, either the pi bond was at here or the pi bond was here. If someone says, sir, pi bond here, this is identical to this one. This one. If someone says pi bond here, this implies they are identical to this one. See the technique. Carbon skeleton remains same. We can't change the carbon. We have to add pi bond. How many pi bond? 1 mole H2. 1 mole H2 means per mole. This implies 1 pi bond per mole. A skeleton remains same. Only 2 compound gives this compound on hydrogenation by adding 1 mole hydrogen. They are identical. Therefore, we have to learn this technique. See this. What about this one? The question is simple. See, 1, 2, and 3. Understand? Yeah. You, the people, are very sweet. Once upon, in 2008, I was there at Narsimkunda. Do you know about Narsimkunda? The Narayana campus? See, I was there for 32 days, continuously, and teaching all Telugu students. See, how many pi bond is here? How many alkene can give this? Either pi bond can be here, and both are identical, or pi bond can be here, or pi bond can be here, or pi bond can be here. The answer is how many? 4. In this case, it is very simple. Suppose 3. 1, 2, and 3. Because it is again symmetrical. This half is equal to this half. 1, 2, 3. See this. In this way, we can solve such type of questions. How many isomeric alkenes from each one type product obtained after hydrogenation by adding 1 mole H2 per mole? That is a question. See, let us see some more example. Write the hydrogenation product of following compounds. cyclohexene, cyclohexa 1,4-diene, cyclohexa 1,3-diene, see. The answer in such case is very simple. Hydrogenation product. Just remove the pi bond and you will get the answer. Direct questions are very simple. It will consume how many mole of pi bond? Just 1 mole. Just add 1 H2 and you are getting this. Carbon skeleton remains same. Just add 2 mole H2 and you are getting this. Carbon skeleton remains same. This will also consume 2 mole hydrogen and the skeleton will be cyclohexane. This will consume 1 mole and this is your answer. This will consume 1, 2, 3 mole. This is your answer. This will consume 1 mole. This is your answer. See this. In this way, we go for hydrogenation. The next point is, this is about hydrogenation. Now the next concept is, can this concept be used with monochlorination? Yes. See, an organic compound with molecular formula C7H12 has 5 isomeric, 4 isomeric alkenes. Has 4, just a minute. Has 4 positional isomeric alkenes. Which on hydrogenation gives another compound, another saturated compound, hydrocarbon with molecular formula C7H14. C7H14. This compound on monochlorination gives 5
H2
structural positional isomeric chlorides, one of which is 1-chloro-1-methyl cyclohexane. See this. This question looks like a demon. Very tough question. Seems to be very, very tough. Organic compound, unknown organic compound, 4-positional isomer, alkene, hydrogenation, unsaturated hydrocarbon, molecular formula this, compound monoclination gives this. See this. That is the beauty of organic chemistry. It is just like a spin bowling. Just twist the hand and you will get another method. Sometime off break, sometime leg break, sometime googly. See, how to solve these questions? It seems very tough, but for you the people, it is not tough. It's very simple, damn simple question. How? See, organic compound, C7H12, 4 isomeric alkene, hydrogenation, saturated hydrocarbon, C7H14. This tells you what? 1 pi bond. 1 pi bond is there. Now, what is the skeleton of this one? I do not know. This tells you what? Chlorination. How many? 5. And one of them is 1-chloro-1-methyl cyclohexane. One of them is 1-chloro-1-methyl cyclohexane. What this mean? The question is simple. Suppose you are traveling about the riverside and you get a corpse of a snake. See. And why snake? Just consider it was a corpse like dragon. Then immediately you can say that it is not for the lion or tiger or snake. It belongs to the dinosaur family. See, in the same manner, as soon as you get this compound, the concept is clear. All the alkene will be like this. And again test. 1, 2, 3, 4, 5. Yes, this will have 5 monochloride product. How many alkene? See, just try to solve this. Either this will be alkene or this will be alkene or this will be alkene or this will be alkene. See how simple this concept is. Don't go by the length of the question. In organic chemistry, you may get questions in longer sentences. But practically, they are very simple. The idea is once you have to consider the concept of hydrogenation, monochlorination, and we the people at Kota, we have developed this chapter in such a way so that any layman can solve these questions very simply. That is the beauty of this part. Hydrogenation. Is this a simple question? No, it is not a simple question. But the concept is very simple. See, next. An organic compound see, this question has already been asked in competitive exam. How many unsaturated compounds with molecular formula C5H8 on hydrogenation gives 2-methylbutane? See this question. Option 3, 4, 5, 6. That is the beauty of organic chemistry. If you are not the master of problem solving, every question is likely to be wrong. But it is not so. It is very simple. See, the reactant is C5H8. Product is 2-methylbutane. Just write the structure of 2-methylbutane. 1, 2, 3, 4. Just compare these two. What is the molecular formula here? 1, 2, 3, 4, 5, C5. How many hydrogen? 3, 1, 2, 3, 6, 7, 8, 9, 10, 11, 12. What is the DU? What is the DU? What this mean? You have to arrange 2 pi bond on this skeleton. In how many ways 2 pi bond can be arranged? See, suppose 2 pi bond at simultaneous one carbon, alkyne. There is only one alkyne possible. We can't have alkyne like this. This is wrong. Why? The valency exceeds. We can't write alkyne like this. Why? The valency exceeds. Only one alkyne can be possible. Let us see other compounds. 2Du, 2 pi bonds. 2 pi bonds, 1 and other. It can't be here. If you write here, the valency exceeds. 1 pi bond, you can't write here. Valency exceeds. So, a pi bond here and a pi bond here, or a pi bond here and a pi bond here, so that valency should not exceed. See this. In this case, the valency is not exceeding. In this case, the valency exceeding. Carbon is similar to dog or goat. It has only 4 legs. It can't have 5 legs. See this. Now the answer is 3. What about this question? How do you rate this question? Is this tough? Sudhir, do you think that this is a tough question? No, it is simply question concept, a simple concept. Hydrogenation. All alkene or alkyne will give the same product. The skeleton remains same. This part belong to nomenclature. This part belong to du. It is neither using mechanism nor using stereochemistry. These are the very, very simple lollipop questions which anyone can solve. And again remember, if you want to appear, succeed in any exam, it is the number, marks matter. Whether you are getting marks in mathematics or physics or physical chemistry or organic chemistry, it hardly matters. That is the crux. I have already told you my experience. I was a voracious reader. I studied a lot. But what happens? I could not get succeed in civil service exam. Why? The reason is very simple. I did not get the marks. And therefore, always eye your marks. Understand? With this, we have covered the hydrogenation concept. And in the next class, again remember, day after tomorrow we have Deepavali, and therefore no class will be there on day after tomorrow on the 1st. Okay. The next class will be on Saturday. Thank you.
Okay, sir.
Any doubt?
Thank you, sir.
ठीक है, thank you.
No, sir. No, sir.
Okay, thank you.